Okay, so today we're going to go over assemblies and constraints. Now, everybody has downloaded these files, they've moved them into their folder they created, and we're ready to actually start a brand new assembly. Now, before we do that, I want you guys to tell me, what do you know about assemblies, just from what we've talked about in class? Those of you that did the Canon exercise, what do we know? Ruben? Okay, so merging smaller parts into a more complicated object. Robbie? That's what you were going to say? Mahi? Mm-hmm. I love that my examples actually make an impact. All right, so Mahi says, at the beginning of the course, I held up a marker and talked about all the different components of the marker. So the lid, the body, maybe the part that holds the ink. An assembly is taking all of those parts and putting them together. So that is correct, you guys. So an assembly file, and I even put the file extension here on Canvas. It's a .iam file, which stands for Inventor Assembly. So it's different than our IPT files, which stand for Inventor Parts. So it's a totally new file type. And what it does is it takes the parts you've created, you've already made them, they're saved, they're good to go, and we apply things called constraints and joints to them to link them together. So taking that marker lid and showing the program exactly where it goes, how far it goes on, how it attaches, how it moves. Okay, so in an assembly, we can fully fix parts in place so that they're, glued. They don't move, don't twist. There's no degrees of freedom. Okay, we can also place parts in there that maybe spin or turn or lever or pulley or have movement to them. Excuse me. Now I'm going to stretch your memory here. When I say degrees of freedom, what does that mean? We talked about this quite a while ago when we did constraints in our 2D sketches. Mahi. Okay, so how and where object can move. So her example is if you have a shape, and I'm going to go further and say, let's say you have a line and you've constrained the two ends of the line, but you haven't constrained where that line's located. She says if it can move up and down, you still have 2 degrees of freedom because it can still move up and it can still move down. So degrees of freedom are how many different directions it can still move. This works the same for 3D constraints. So all those concepts we learn with the 2D constraints, here's the good news, we can actually still refer back to them for our 3D constraints. So in Inventor now, you should have Inventor open, and for this assembly, or for this, assembly, I'm using Inventor 2022. We're going to open up a brand new assembly file. So I want you to go File, New. We are in inches, so that's our English folder. And we're opening up an standard in.iam. Okay, so come down to the second section here called Assemblies, find the standard in inches, and go ahead and click Create. And you'll notice when your assembly file opens, it's going to look a little bit different than what the part file opened. Okay, so when you open a part file, at the very, very top, the tabs you have are typically 3D model and then sketch and then some other different tabs. Here in an assembly, you're going to see that the first 2 tabs are called assemble and design, and then we get to 3D model, sketch, and et cetera, et cetera, et cetera. So it is a little bit different right from the get-go. We still have our model browser here, so we still have the menu on the left-hand side. Which is very familiar and very useful. We're going to use this a lot here in our assembly. So the first thing we're going to do is place in what's called our base component. And this works the same way as when you draw things in 3D. So when we draw a 3D part, what's a base? Most important object. What do we use a base for? Let's see if somebody else has an answer. Connor. Good. So Connor says the base is what you build the rest of the object off of, and that is perfect. Matthew. Yes, it's the object that's grounded, or it's the one that's locked in place. Good. So this works the same way with an assembly. So again, all those lessons we learned with 2D parts or with building parts applies to this. So when we place our base in our assembly, instead of it being the first extrusion or first revolve that we do, it's the very first part we put in here. It's the very first part we fully constrain in place. And like Connor had said, it's the one that everything else is going to be built off of. So that's what we're going to do. I want you guys to come up to the top left-hand corner. There's a button there called Place. And if yours says something different, like if it says Place from Content Center, just hit the drop-down and choose Place, please. So click on Place, go into that folder that you just made. And you're going to be placing in your base part. So find the part called Base and click Open. Okay, so when you click open, it's going to be attached to your mouse. It does not matter where on your screen you dump it because we're going to constrain it exactly where we want it. So just dump it somewhere on your screen and you'll notice you still have it attached to your mouse and you can place as many of these in here as you want. Okay, so that's the way assemblies work. You only have to design your part once, but you can place as many of them into the assembly as you want. So it's kind of awesome. Think of it like wheels on a car, for example. I think we all love or hate that one by now. So when you design a wheel for a car, you only have to design one wheel, and then you can place all 4 of them in here all at once. So it saves you lots and lots and lots of design time. Okay, so place your base in here. Now you're going to notice if I click and drag that base around, you can still move it freely on your screen. Now we don't want that. Just like with a sketch, you know, when we do our fully constrained sketches, we want our assembly to be fully constrained as well. Just going to move my microphone here. There we go. Okay, so to do that, we're going to come up to the top of our screen and there is a constrain button. It's in the relationships panel, and I want you guys to left click on constrain. And the first thing we're going to do is fully constrain this base in place so it cannot move. Okay? We're going to use something called a mate constraint. And a mate constraint, think of it like a sandwich, honestly. You take your left side piece of bread, your right side piece of bread, and you slap them together so that those 2 faces touch each other. That's the way a mate constraint works. It takes 2 things and it makes them touch, facing each other. Okay, it doesn't line them up, it makes them touch. So we're using a mate constraint. It's the very first one under type. If you hover over type, it says mate. And if you come over to solution, it's this first button here called mate as well. So make sure you're on the mate type and the mate solution. What we're going to do is we're going to fully constrain our origin of our base part here to the origin of our assembly. So I want you guys to come over to your model browser. I want you to expand your base part and expand the little origin folder under the base part there. Okay. Now you're going to find your YZ plane. So left click on the YZ plane. Don't even try to grab it. You could turn on visibility and grab them in your graphics window if you want to. It is much, much, much easier just to grab them in the model browser. Okay, so left click on the YZ plane for the base part. You'll notice it highlights on your screen. Then we're going to open up the origin folder for the assembly. So come up to the very, very top of your model browser and find that big origin folder here. Expand that and click on the YZ plane for the assembly. And what it does is it mates or it sandwiches those 2 planes so that they're touching. Once you have that, click apply. Yes. Once you hit apply, though, they should line up though. Oh, okay. Mahi's saying hers aren't, they're not actually touching each other. They're just lined up. That's okay, because right now all we're doing is putting one constraint on. So if you look at my hands, you can actually, they're lined up when they do this. They're also lined up when they do this or this or this, right? All you're doing is saying these 2 faces need to be in line here. Does that make sense? Yeah. Okay. Do you have any other constraints already on there? Were you trying to jump ahead? Okay. Under solution, just choose the other solution if you have to. It's possible your planes are flipped. So click apply and it should lock those 2 in place. If you have that, we're going to move on. We're going to do the XZ plane for our part to the XZ plane for the assembly. Do the exact same thing, mate constraint, click apply. Now if I close this, I close my little place constraint dialog, I should be able to grab my base part and it only moves in one or in one sort of direction right now. So like Mahi said earlier, it has 2 degrees of freedom. It can move forwards and it can move backwards, but I can't move it up and down anymore, and I can't move it left to right. Okay, so we've constrained some of its degrees of freedom, so it can only move along that one plane. So we're going to constrain that last bit of movement. We don't want it wiggling around on our screen. So click on constrain. We're going to constrain the XY plane of our part to the XY plane of our assembly. But right away, I noticed there's going to be a problem. Instead of it jumping together and showing me a preview of what it's going to look like, it didn't do anything. And the reason for that is because of the other 2 constraints we placed on here, it can't line those 2 up. So we have to use a different type of constraint here. We can't use a mate constraint. We have to use a flush constraint. So to switch to a flush constraint, underneath solution, you just come over to this other button here called flush, and it even shows you what it does. Instead of slapping those 2 faces together, it lines them up so that they're flush to one another. So if you choose that, notice right away my preview jumps together, and click apply. And now when you go to drag your box around, or your base part around, you should get a little error symbol on your mouse. When you left click and try to drag it, it's saying, nope, this guy can't move anywhere. So we know it is fully constrained in place. There is 0 degrees of freedom left to it. Okay, at this point, please go save your assembly. Yes. Okay, so you're just missing something then. I'll come take a look. I'm just going to reselect what you XY here, or Z right to here. Well, there we go. That was probably all of it. Right click, edit, select, and so here, there. I think you're good. Sure. All right, guys. Save your assembly, and I'm going to quickly do that as well. And we're ready to actually start putting different parts together. So now that we have our base part in here, our base part is fully constrained. Now we're ready to start bringing other things into here. That's where I'm putting it. Okay, so we said to call this one, I just want to make sure I do it right in the recording here. We said to call this one last name, first name, matching assembly. Just like that. Click save. Okay, so we're ready to start placing our parts in here, and we're going to start with some of the easier ones and then move up to doing different constraints. So in this tutorial, as we've already talked about, I'm going to go over the mate constraint, the flush constraint, and I'm planning on teaching you guys the tangent constraint as well. Now that is not all of the different constraints, but that will actually get you quite a bit or quite well set up to do a lot of different assemblies. So those are 3 of the big ones. The other big one that we're going to talk about another day possibly, if not this course, then in the next course, is the angle constraint. So if you're practicing on your own, the angle constraint would be a good one to go look up. However, I'm going to teach you the more common ones that we typically use. So now we're going to click on the place button, and we're going to start by placing in our let's go with the rectangle and the square. So let's grab the rectangle. There it is. So grab your rectangle, click open. We only need 1 of it, so go ahead and place 1 on the screen, then right click and choose OK. I'm going to spin this guy so I can see it is, and let's change this visual style. There we go, so we can actually see what's going on. So I'm going to spin this guy so that we can see where we want it. So what we're doing, this is, if you guys haven't recognized it by now, I made this one, but this is kind of like one of those child's play blocks where you take those little shapes and you put it in through the holes. I thought this would be a really good one for us to practice the different constraints. So we're basically, this is back to preschool here. We're going to fit the right shape into the right slot. If you try putting it in the wrong slot, it will not work. So let's click on our our constraint. Click on constraint. And we're going to do a mate constraint. So just the default setup. So under type, it's mate. Under solution, it's mate. And we're going to start by just lining up the back face of that rectangle as far into the hole as it will go. So I want you guys to place, or sorry, constrain. I keep using the wrong word there. Constrain the back side of this rectangle here by left clicking on it to the back side of the hole here. Okay. And the reason I'm doing it that way and not lining up the front of the face is you want to make sure it's only going in as far as physically possible. And if you spin this, you'll notice that it still sticks out, and I designed it like that on purpose. So if you lined up the front of the faces, then it's incorrect because it's actually extruded into the block, which is physically impossible. Okay, once you have those two faces lined up, click apply. The next thing we need to do is line up, and I'll show you. I'm going to close my constraint dialog box and just drag this guy out of the way. So notice right now he still has lots of degrees of freedom because he only has one constraint. So I'm just going to drag him out of the way like this. Then I'm going to constrain the short side of my rectangle here to, and I'm going to spin my screen so that I can see it, the short side of the hole right here. Click apply. And now if we look, now he's pretty constrained. He's lined up at the back, he's lined up. So all he can do is go up and down. So we need to place a constraint to line up the long face of the rectangle here to the long face of the hole there and click apply. I know. Click, click, click. All right, so now if we spin this guy around, that rectangle is fully in place. There's no gaps around here. And I'm going to show you guys one more thing. And those of you that are working ahead, I want you to pay attention to this. So I've placed my rectangle. Everything's locked. I get the error symbol if I try to move it. Now, how do we know whether there's any interference between these two parts? And what interference means is how do I know if there's anything that's overlapping or doing something that's physically impossible? Inventor can check that for us. So what we do is we come up to our Inspect tab. So I want everybody to do this. Go up to your Inspect tab. And there's a button here called Analyze Interference. So left click on Analyze Interference. And it's going to say define set 1, define set 2. To be honest with you, I just usually grab everything all at once. So I draw a box around everything, make sure you don't miss anything, and then click OK. If there are no interferences, you should get a pop-up saying there were no interferences detected. If you get a pop-up that says there are 1, 2, 3, 4, etc. interferences, you need to go back and fix your constraints because you have something overlapping. Does that make sense? Okay, and I'll show you what that looks like really quickly here. If I change one of my constraints, let's say, I'm just going to give this guy an offset so that I know he's overlapping. Let's say I did one of my constraints incorrectly. I analyze interference. I draw a box around everything. I click OK. This is what you get if something's overlapping. It shows you, okay, you've got a problem right here. You've got these two volumes are overlapping. That's not physically possible. And it tells me how many interferences and what volume it causes. Okay, so that's what it looks like if you have an issue. If you get this, you need to click OK and go fix that issue. Are there any questions about that? So this is what I want everyone to do with their assemblies before they hand them in, just to make sure there's no issues. All right, go ahead, click save. I'll do one more with you. Actually, I'll do a couple more with you, and then I'm going to let you guys work on this on your own for the rest of class. So next, let's do the circle next, because the circle uses a little bit of a different constraint. So I want you guys to place in this circle. Okay, and right now he's just free on my screen. Now to start with, it starts the same way the rectangle did. I'm going to use a mate constraint between the flat face of my circle and the flat back side of the hole here. So that starts the same. Now what's different, if I just drag this guy out of the way here, what's different is the next part. Now with the rectangle, we were able to constrain the flat sides of the rectangle to the flat sides of the hole, right? That was nice, easy, that made sense. We don't have any flat sides with the circle. We have no way to constrain those flat sides together. So what we do instead is we constrain the center axes of the circle to the center axes of the hole. So we do this by hovering. We're doing a mate constraint. It's still called a mate constraint. You're going to hover over the edge of your cylinder until you get that green axis pop up through the middle of the cylinder. It should look like the way it does on my screen there. Okay, so click that, left click on that to grab the center axis here. Do the same thing with the hole. Hover over the circular part or the curved part of the hole till the axis pops up. Left click on that. Click apply. So what that did is it constrained the center points. Now, I know we can't see it, but right now our circle is still left with some degrees of freedom. Does anybody know what it is? Mahi. What's that called?
Spinning, rotating.
Sure, spinning, rotating. So all we've done is we've lined up the back of the circle and we've lined up the center point, but think of it like, oh, what's a good example? I don't know, spinning a donut around on your figure type of thing. It still rotates around on its center axis here. So kind of like a threaded fastener or anything like that. It still rotates around like this, and that's okay. Because there's nothing stopping it from rotating, there's nothing physically capable of stopping it, we're gonna leave it like this. So this is one of the cases where we're still gonna leave some degrees of freedom. Does this make sense? Does anybody have any questions? All right, hit that save button, guys. Okay, well, that's something we're going to deal with afterwards, not in the recording, okay? All right, so the last one I'm going to do with you guys now, we're going to spin our base around, and I'm actually going to do this one with you guys, the sphere, because the sphere uses a different constraint called tangent. Okay, so spin the base around so you can see the donut-shaped hole on the back side here, and we're going to place in our sphere part. Okay, so we just need one of them, although actually with this one, you could place in more than one if you want to practice because there's lots of room. Now, what we're doing is we're going to insert this sphere in there so that it can still travel around on there. Think of it like one of those, those like 3D puzzles or mazes where you hold it and you wiggle it around and the little metal ball moves around on the maze inside this little box. That's what we're doing here. So we're putting the ball inside there so it can still move around in the circle. To do this, we're not going to use any mate constraints. We're going to use a constraint called tangent. And let's see if you guys can explain. I think you all remember, but see if you can explain what tangent is. I'm going to call on Krisha.
Yes.
Okay, so sorry, say that louder. Okay. Okay, you're on the right track, but can it do something other than circle to line? Circle to arc, okay. What about circle to circle? Circle to circle, yes. There we go. Your math teacher would be happy. All right. So Krisha had a good, she had the right idea. She said it connects a circle to a line or to an arc or to another surface so that they're smooth. But like Mahi said, the mathematical definition is so that they only touch at one point at a time. So if we zoomed in forever and ever and ever, infinite amount of zooming on this, they would still only touch at one point. Okay. In our terms, as far as we care with the assembly, tangent is going to make it so this sphere sits inside of this surface here. And if you zoom in, I know it's kind of hard to tell, but this donut actually has a curve to it. You can kind of see it better here with the inside one. It's actually a curved cutout. It is not flat-sided. Okay, so we want the sphere to sit right inside that curve there and kind of get held inside of that. So click on Constrain. Now in Constrain, we're still on the Assembly tab here. We're going to click on the third button under Type. If you hover over it, it's called Tangent. So click on Tangent. Then we're going to click on our sphere. And you have to click what you want your sphere to be tangent to. I'm going to pick this big curved surface inside of the donut here. So I'm choosing like the outside part of it. You could choose either the outside or the inside. They would both work. So clicking on this big curved surface here. Okay, so I can see right now what it did is it's making them tangent, but it's moved it to the outside of that surface. That's not what I want. So underneath solution, before I click apply, I'm going to choose the other solution here called inside. and it will move that sphere to the inside. Okay, so if it jumps to the wrong side, just choose the other solution option to move it to the side where you want it. Once you have that, go ahead and click apply. And you should now be able to grab that sphere and it should still move inside of there. So it still has some degrees of freedom, and that's good. That's what we want. So we're actually only placing the one constraint on this part. I gave you guys a virtual fidget spinner. Here we go. All right. So there, I've done examples of the mate, the flush, and the tangent with you guys. Now for the rest of this activity cube here, you're going to use those constraints to place in each of the rest of these shapes along the other sides. Okay, so if you haven't yet, quickly save your assembly, and then one at a time, you're going to click on place, and you're going to bring in each of the rest of these parts and constrain them in place. And I'm going to end the recording here, and I will post it on Canvas so you guys can access it later if you need.